Alrighty, so today we're going to, you know all those kinematics formulas from grade 11? You know your A equals delta V over delta T, and your V bar equals D over T.
Nope.
Your V bar, no?
Nope.
You don't have them committed to memory?
Nope.
Well, that is unfortunate. Today we're going to derive some kinematics. Is that right?
Yeah. So just notes or what?
Yes, this is notes. Equations. All right. So what I'm going to do is I'm going to take some of the kinematics equations that you might be familiar with when I show them to you from grade 11, and I'm going to give you 3 brand new spanking shiny formulas to do problems with. And you'll say, "Oh, Mr. Bennett, why didn't you give us those last year?" Because they're going to be so much fun. Actually, you will find that some problems are a little bit easier once you've got the formula. Now, the first question that everyone always asks me is when I'm done is, do I have to know how to derive them? Sort of. Okay. On a problem, I'm not going to ask you to derive the formula before you can use it. I'm just going to say, go ahead and use the formula. But you have to see where they come from. Okay? So one of the curriculum outcomes is you have to, I'm going to call it experience formula derivation. It's not going to be on the test. Okay? It's going to be on the exam. It's an experience. So just sit back and enjoy the experience. Okay? I'll start you off easy. I like to call the first one equation number 1.
I just spell that.
Do you remember, Justin, A equals delta V over delta T? Yeah? A equals delta V over delta T. Now, to derive a formula means to take an existing formula and sort of maybe combine it with another one or 2 or 3 others and sort of put them all together and come up with something a little bit more simplistic that sort of does a better job. Sort of like a new and improved version. So what I'm going to do is I'm going to replace, because you might remember that delta V simply means take the final one and subtract the initial one, right? Change in velocity means Vf minus Vi. So what I'm going to do is I'm going to take this bit right here, and I'm going to plug it into the formula for delta V. And I'm going to write A equals Vf minus Vi all over. And I'm just going to sort of let the delta T become a T. And the reason for that is change in time is the same thing. Maybe I will explain it. Delta T would be Tf minus Ti, final time minus initial time. But generally, the initial time is almost always what? 0. Okay?
That's my note.
Yeah, the initial time is almost always 0. So 99.9% of the time, you can sort of ignore it. Isn't that a pencil?
No.
Oh.
You're fancy, eh?
You are, Mr. Fancy. So that's kind of why I sort of, just simplicity's sake. Okay, now I'm going to rearrange that, and I'm going to take the T up to the other side, and it's going to become AT is equal to Vf minus Vi. Does everybody see the mathematical process there? I'm hoping that by grade 12 you've done enough pre-calc that you know multiply both sides by T, right? Multiply both sides by T, those guys cancel, right? You get T times A or AT. Yeah, everybody knows that? Good, they're comfortable with that? And now what I'm going to do is I'm going to take the Vi to the other side, and I'm going to have plus Vi plus AT is equal to Vf, which we usually write as final velocity is the initial velocity plus the acceleration multiplied by the time. Vf equals Vi plus AT. And that, my friends, is known as kinematics equation number 1. The final velocity is simply the initial velocity plus the acceleration multiplied by the time. And if you stop and you think about it, it sort of makes sense, right? Whatever the final velocity is, you take the initial velocity, and you add on whatever is increased over a certain amount of time at a certain acceleration, right? If I start at 0, and I accelerate at, say, 3 meters per second squared for 2 seconds, how fast am I going to go at the end of that 2 seconds? 6. Right? It's actually quite simple when you stop and think about it. I've made it far more complicated than it really is.
Nice going.
I will warn you, this is the easiest derivation. The next two will boggle your mind. Some good mental gymnastics first thing in the morning.
Should did something else on a Monday.
Yeah, sort of limbered you up a little bit.
Yeah.
Some yoga or something.
Yeah.
Mental yoga. Equation number 2. Equation number 2. Now, the equation number 2 is the good one because you always had, do you remember, and don't write this part down, do you remember having to deal with V bar equals d over t? Anytime you had to find d, the displacement, you had to find the average velocity first. Remember always having to do that? And always making that mistake and screwing it up and that kind of stuff? This formula will get rid of all those problems. Okay? You just have to go through the derivation process. Okay, so I'm going to write, since displacement is the area under a VT graph. This is the basis that this whole derivation sits on. Displacement is the area under a VT graph. Since displacement is the area under a VT graph. Let's see if it recognizes my handwriting. Since displacement is the area under a, oh, pretty close. The computer understands me. Since displacement is the area under VT graph, I'm going to draw you a graph. And you should draw it too. Okay? Here's the actual graph like this. And this is a VT graph, right? And so displacement between 2 points is the area. And I'm going to go in blue here. I'm going to pick this time right here. I'm going to call this TI. I'm going to pick this time right here, and I'm going to call it TF, initial and final time. Okay? And I'm going to say initial velocity here is 0, and I'm going to say final velocity is right there. Hold on a second. Yeah, it's all right. Yeah.
Mr. Bennett.
I knew I was messing up, but at least I knew I made a mistake. Yeah, that's the initial velocity there. That's the final. I apologize.
I'll have it.
I apologize.
You're smart dude.
Okay, so I got TI, TF, I got VI, we got VF here. So the displacement is going to be this area here. Does anybody know what that shape is right there?
Yeah.
No? It is a quadrilateral, that's good. A quadrilateral is simply a 4-sided geometric figure, right? Here's what I'm going to do for it. You don't need to write this down because you can't. I'm going to pull that out to the side, and then I'm going to rotate. Now, can anyone tell me what is it?
Square.
It's not a square.
Yeah, it is.
It is a trapezoid. Very good, Troy. It is indeed a trapezoid. Most people think of a trapezoid like this, you know, like the things that the elephants stand on at the circus, right? Most people think of that as a trapezoid.